Hey everyone, welcome to my HashiTalk. And today I'm going to be talking to you all about Waypoint plugins and maybe how you could build one from scratch with just a little bit of help. But before that, I just want to introduce myself real quick. My name is Joe Rajewski. I joined HashiCorp a few months back, and I'm a software engineer on the Waypoint ecosystem team. But prior to joining the team, I was pretty active on the Waypoint GitHub repo. You may have seen me around there if you've been poking around. My username is Paladin DevOps. But who is Paladin DevOps? Well, even outside of HashiCorp, I was a big HashiCorp nerd. I got certified in Terraform, Consul, and Vault. I've run Nomad clusters, Consul, clusters, Vault, Waypoint, Boundary, you name it. I've tinkered with it in some fashion. But really outside of work, though, I love my new kitty, Suki. I've had her for about a year now. And she takes up quite a bit of real estate in my apartment with her plentiful cat toys and furniture. But yeah, when I really get out of my apartment, I love to go snowboarding in Baltimore, Maryland. There aren't really many mountains around, so I do have to travel to make that happen. But this year I got an Epic Pass, so hopefully I can get out and see more of the country. But yeah, outside of that extreme activity, I love heavy metal and classic rock music, but pictured on the slide here is a pre-pandemic version of myself with the singer of one of my favorite bands called Fit for an Autopsy. But that's enough about me. Let's talk more about Waypoint plugins. So what are they? Well, our documentation says they are this, but I think of them as apps that are actually separate from Waypoint, but that Waypoint uses to perform the various operations that it can do, which include like builds, deploys, and releases currently. But what's a component? Because that's a part of the definition that we talk about in our documentation. Well, a plugin, or excuse me, a component is actually kind of like a type of a plugin, but a plugin can implement interfaces for multiple components. So a builder plugin, or rather a plugin that implements a builder interface, could also implement a registry interface or a platform interface and act as multiple components, but be the same plugin. So here's just a couple examples of those interfaces. Build, deploy, and release are the highlights of the Waypoint lifecycle. But yeah, these are what those interfaces look like. And these code snippets are pulled from the Waypoint plugin SDK. And basically, in your Waypoint plugin, if you implement these interfaces and your plugin uses them, then your plugin now can act as a builder if it implements the build function and returns an interface, and so on here with platform. If it implements deploy func, it becomes a platform plugin, and release manager requires a release func. But yeah, let's get into a demo and I'll show you all how to make a plugin. All right, so now we made it through the super fun slides. I'm going to do what I promised and show you all how to create a Waypoint plugin. But we're actually not going to be doing this completely from scratch, and we are going to use a good bit of help. This Waypoint plugin examples repository on the Waypoint, excuse me, the HashiCorp org on GitHub has a script in it that can help us get started with creating a plugin way faster than trying to figure it out all by yourself. So something I want to add here, though, before we get into it, is that this is actually how I got into plugin development when I was still a part of the community before I worked at HashiCorp. I had really little idea where to start, but the documentation led me here, and this is definitely a great way to get started. So let's first clone down this repository, and I'm going to open up my Waypoint colored terminal, and we're going to hit clone. And let's move in there and see what is going on. And at first glance, it looks like some basic Go stuff, Go mod, Go sum. There's also a plugins path, which contains some examples of plugins. We're not going to look at that right now. We're going to focus more on generating code for a new one. But if you need to check out some example code for a plugin, you can check there, or currently at the Waypoint repository. But in the template path, we have a bunch more stuff, including a makefile and a Docker file used for building the plugin, but also some additional folders, including builder, platform, registry, and release. You probably remember that from just a few moments ago when we talked about the various different kinds of plugin interfaces that you can implement with a plugin. But yeah, for this demo, we're only going to be implementing the builder interface because what I'm going to be doing is creating a builder plugin for Packer to build Packer images. For those of you who don't know what Packer is, it's another HashiCorp product that specializes in building machine images for any platform you can think of, whether it be VMware, Docker, AWS, GCP, Azure, many others. If you can think of it, there's probably a plugin out there for it in Packer. But anyway, that's the plugin we're going to be building. So let's clone this template into a new template that we can use for our new plugin. So let's see what clone.sh wants from us. And it looks like we need a name, a location, a name for our plugin, and a location on our file system to store the new plugin code, and the name of the Go package for our new plugin. So let's give it that and see what happens. We're going to call it Packer, and we are going to put this in my Go source path at github.com, and then my personal GitHub or Paladin DevOps. And we're going to call it waypoint-plugin-packer. And the Go package name is going to be named the same thing. So we say github.com/paladin-devops/waypoint-plugin-packer. Excellent. Okay, now let's change directories over into our new plugin. And it looks just like the template path did. All the same content is here, except it's now some values have been populated in these files specifically for a plugin named Packer. And that's enough in the terminal, though. I'm going to pop over to my IDE, and I like Golang, so that's what I'm going to show you all here. All right. We are going to start off in here by looking at main.go. And right off the bat, you can see a few import statements. There's 4 of them, in addition to the Waypoint plugin SDK. But these first 4 are packages that are in this repository. And they include the builder, platform, registry, and release packages. But I mentioned we're only going to be creating a builder plugin, so we're only going to need that particular package. So we'll clean this up in just a second. But just wanted to point out here that your plugin can implement more than one interface. Like I could have this Packer plugin do what I initially said, which is act as a Packer builder, run Packer build to create a machine image. But I might also want to publish that image metadata in HTTP Packer, which sounds like a pretty good use case for a registry plugin. And therefore, we could potentially also implement the registry interface to make this plugin act as a registry as well. But in this case, we're just going to be making a builder. So let's get rid of the interfaces we're not going to implement. And Golang cleaned up my imports for me, which is great. And yeah, let's take a look at our builder package. All right, start off here at the top. We have a few more imports here, a couple from the Go standard library, but something extra here is from the Waypoint plugin SDK, and it's a package called Terminal. And this package is used for outputting information to whoever's using your plugin on their CLI, so that way they can kind of see what's going on with their Waypoint operation. But we'll see that in action pretty soon here. Next, we have the build config struct, and this configuration actually defines what can be what knobs can be turned in your waypoint.htcl for your plugin. In this case, the template has a configuration for the directory, and this can be used during our plugin build operation or our Waypoint build operation if we need it. If we don't need it, we can probably get rid of this, but this is what the template provided us. We're going to be adding a couple more things here in a bit for Packer specifically, but we're going to leave it as is for the moment. But the way that this is consumed by Waypoint is through this config interface. this is what actually enables the configurations to be set in your waypoint.htcl. And we can see right here that this b.builder, or excuse me, this builder type, which is defined just above the function here, is returning the config field from the struct. And that's how Waypoint consumes it. But taking a closer look at this struct, the builder struct is actually what's implementing the builder interface to make this a builder plugin. The configurable interface is optional, but in general, plugins tend to have configurations. It's not absolutely necessary, but they can, and this one does. But builder becomes the builder plugin by implementing the function build func, because that's the interface for a builder plugin. And build func returns b.build, and b.build is featured just a little bit further down this file, which is just another function with the builder type as the receiver. And in this function is where you actually write the code that's going to perform the actions of your plugin. In this case, it's going to be a packer build. So the packer build command is actually going to be initiated from this build function. And yeah, we can just get started on making that happen. So let's do that. All right, so the first thing I'm going to need is something that can execute a command in Go. And fortunately, the Go standard library has something like that for us. And it's in a package, which is a package called exec, which allows us to run commands. And we're going to say the command I want to run is packer, but we can't run packer build right away. For people out there who use packer, you must know that you have to run packer init first to initialize your packer configuration and get any plugins that are needed and all that important stuff to make your build happen. So packer init, and packer init is followed by a path for wherever your packer configuration exists. So fortunately, we have a config option already defined in our build config called directory. So we can actually use this and say that we want to use b, which is our builder.config.directory. And that's great because now the user can configure where they want where their packer configuration is, even if it's not in the same directory as the waypoint.htcl file. So now that we have that, we can run, or rather we're going to set error equal to o.run, which actually runs the command and returns an error. And we're going to check if that error is nil before we move on. Error is not equal to nil, then we are not going to return a binary, and I'll get into these this return type in just a few minutes here. But we're going to return nil and the error back to whatever is calling this function. So now at this point, the packer configuration will have been initialized because packer init has run with the directory that it needs. So with that done, the next thing we need to do is actually run packer build. So let's just copy this this code we just used. Zoom in here. All right, packer build. And we're going to keep the same directory because we want to build the configuration that we just initialized. So it's pretty nice that we can refer back to the same configuration. And these have already been instantiated, so we don't need a colon there anymore. And that's looking pretty good because packer init's there, packer build is there. Yeah, I think we're good. So let's give this a dry run. First thing we need to do though, before we can use the plugin, is build it. So let's run make build because we have a make file here. And this is just going to run go build with excuse me, in order to create the various variations of the binary based on your operating system. I'm running on Mac, so I'm going to use the binary that's been copied into Darwin AMD 64. So let's copy that. We need /bin Darwin and Waypoint plugin packer. There's our binary. But to install it though, we can copy this file to a directory that Waypoint reads by default when it tries to search for a plugin. Because in your waypoint.hcl, when you specify a plugin with your use stanza, Waypoint goes and looks to see where that plugin is. So let's, or rather on a Mac, that's going to be in my home path in the library preferences folder. And that'll be under Waypoint, and then the plugins folder within that Waypoint folder. If you're on a Linux machine or a Windows machine, it's going to be a different path. On Linux, it's probably going to be your home path.config/waypoint/plugins, if I recall, but you might want to check the Waypoint documentation to verify that. So we're going to copy that file there, and that part is done. Next, we need to create a waypoint.hcl file, which can actually attempt to use this plugin. So at the top of our waypoint.hcl, we require that there's a project name currently. So we're going to call this HashiTalks builds and add Waypoint on the end there. And we're going to say our app is of the same name. So HashiTalks-build-Waypoint. And we are going to write our build stanza, and that build stanza is going to use the Packer plugin. And we have a config option called directory, and we just want that to be our current directory. That's where I'm going to add the Packer configuration file in just a moment here, after we get to the Waypoint file. So that's the end of our use stanza, and that's the end of build. And we're not going to try and use this build artifact in any deployer yet. So I'm just going to use the exec plugin as an escape hatch really quick, just to run a command for us. And we're just going to say echo done. And close up that use stanza. Oh, messed up the curly braces there. All right. And that should do it. All right, so that's a pretty good looking waypoint.hcl file, pretty simple. It uses our new plugin called Packer. So let's save that guy. And we'll run waypoint fmt just to make sure it's formatted nice and pretty. And now we need a Packer configuration to, actually start doing something with Packer. So let's just call this waypoint, or now let's give it a different name, HashiTalks.pkr.hcl. This is the naming convention for Packer file configuration files. And I've already written this ahead of time, so we're just going to go ahead and copy that in here. And this is pretty simple. It's just going to be pulling down a tagged Ubuntu image and exporting it into a new tag on my local machine. So without getting too deep into this yet, let's save that file. And let's try and run Waypoint build. Similar to Packer, you need to run Waypoint init before you run Waypoint build with a new project. So let's run Waypoint init now. And now our project has been initialized, and Waypoint build is going to kick off our build. And it tried to run the build with our new Packer plugin, but something went wrong. We didn't get a lot of information though, because we didn't output anything into the user that could help us diagnose what's going wrong. But we know there's something wrong because we got exit status 1 here. So we can take a look inside of the Go code and see what's going on. So we've got Packer build here, and this is just Packer build dot, which is our current directory. But in our Packer configuration, there will be hashitalks.packer.hcl. I have a few variables here that are required. They don't have default values. And if it doesn't have a default value, then the Packer run is going to fail if something isn't provided for these variables. So let's head on back over to GoLand, and we are going to take an opinionated stance on what needs to be added here. This is going to now require, for this plugin to operate, 2 variables, one called image and one called tag. So we don't have any configuration like that, though, from the user. There's currently no way to provide variables into the Packer build execution. So we need to add a couple of additional build configs. So we're going to call one of those things image, and we're going to give it an HCL tag and call that image there. And we're going to say that it's an attribute, which means that it is required, it is not optional, and that the user therefore must provide it. Okay, and let's add a second one called tag, HCL, tag, attribute, and great. We're also going to say that the directory is required by labeling with ATTR, because Packer build and Packer init both need a directory. So now back down here, we're going to add a couple of additional flags to be passed to the Packer build run. So we're going to say -var equals image equals, and then concatenate the actual config, the image name from the config that the user provided. So we're going to say b.config.image, and we're going to pass one more variable here, -var equals tag equals, and we're going to say b.config.tag. Excellent. Okay. And again, for people out there who may not use Packer, you can provide variables as flags on the CLI with Packer, just like you see here. It would be key value pairs. Image is the key, and then the value is going to be the configuration that we provide here. But you can also provide things in a file with a flag called var file, and then you pass in the file name. But in this case, we're going to take an opinionated stance, require that the user provide image and tag as variables, and we're not going to accept any files as input variables. So now that that's done, we need to rebuild the plugin. So we're going to run make build again. All right, we've got that created. Now I'm going to use a command that I ran earlier to copy the new binary into the Waypoint Plugins path. So we've got that done. I'm going to clean this up just a little bit, and we're going to try running Waypoint build again and see what happens. So now we didn't get return code 1. We got a little bit different of an error. And we can see here that we are missing a required argument called image. And when I was updating the build config, you probably heard me say a couple of times that labeling something with the HCL tags as ATTR attribute means that it's required. So Waypoint actually detected this just based on those tags. And I didn't update the waypoint.hcl file because you can see right here, the only configuration that we have still is directory. So let's add that additional stuff. And we're going to say our image name is just going to be DevOps Paladin /Ubuntu. And our tag is going to be latest. All right, and I'm going to run Waypoint FMT again because I like things to be neat. And let's try one more time to make this Waypoint build happen. Please stand by. All right, it's done. That only took a few seconds, and our build has completely finished. So let's run Waypoint artifact list builds. And we can see here a few minutes ago, our build failed, but this time it didn't. So there we go. That's our first execution, successful execution of the Packer Builder plugin. But we've got this empty binary struct that's being returned back to the caller. And nothing really useful is being passed in here, but what is important here is that we provide some kind of artifact information back to Waypoint so that in the next part of the Waypoint lifecycle, and what comes after Builder is the registry stanza, we want to provide that information about how can we push this build artifact to some repository. So this is not, or what we just built was a Docker image using Packer. We did not build a binary file. So what we're going to do here is rename this and then give it a couple of attributes. And those attributes are just going to be the image name and tag that we provided as input, but we're also going to provide that back to Waypoint as the artifact. So in order to do that, we need to actually update the protocol buffer definition for this plugin. We can see here we have the message binary that's defined, but I'm actually going to rename this to image. And we're going to give it a couple of fields here, and we're going to say string, and we're going to say image name and string tag. Cool. And if we go back over to Builder, everything's still fine because the protocol buffer code that's been generated for gRPC still resembles the old type binary, but we need this to now change to become image because I just updated the definition here. So let's do that with a command in our make file called make protos. So we have a couple of errors here, and it looks like these are happening in our platform plugin, which we're not going to be using here. So let's go ahead and remove those from our make file. And yeah, it's attempting right now to build the plugin for each type, registry, platform, and release, and builder, but we're going to remove the ones that we don't need. So let's try that one more time. All right, it is done. So this output.pb.go just changed, and it now should have a type that we can use called image. If I search for that in here, yep, there, right at the top. Image, and it's got a couple of fields, image name and tag. So we go back over to builder.go. My IDE is now unhappy with me because there is no longer a type called binary in this package. There is, though, a new type called image. If we can autocomplete, excellent. So we've got image here, and that is our new return type, and binary doesn't exist and it doesn't match the return type. So we need to change that to image. And we're going to fill all of our fields here. And we are not going to use state, /cache, or unknown. We're going to just provide the image name and tag. So b.config.image and b.config.tag. Excellent. Okay, now let's try building this plugin one more time. Make builds. All right, it has been built again, and we're going to copy that plugin to our plugins folder, and we're going to try running Waypoint build once more. Please stand by. All right, so now let's do Waypoint artifacts list builds, and we have a new build, and let's just look at our artifacts. And we can see 10 seconds ago, we pushed a new artifact. We can't, or there's nothing really to inspect here at the moment, but in theory, if we had a registry plugin, which consumed the protocol buffer definition for image, then that image could be used in the next part of the Waypoint lifecycle and could be pushed to some remote repository. Or in the example I mentioned earlier, that could potentially be the Waypoint, the HashiCorp Cloud Platform managed service for Packer. And maybe we could do something with that later on with a deployer plugin or a releaser. Yeah, but that's pretty much it, guys. So that's how you create a plugin from scratch. And I hope this helps you all get started writing plugins. If you have any questions, you can reach out to me or anyone on the team on GitHub or discuss. And we're always happy to help. So thanks for watching this Hashi Talk, and hope you enjoy the rest of the day.